In chapter 3, we'll be looking at integration. If you differentiate the function big F and you get the function small fx, then we call the function big F the antiderivative of f. That means if you differentiate the function big F with respect to x, you get the function small fx. Then we call big F the antiderivative of the function small f. For example, if you differentiate x squared plus 5, you will get 2x. Differentiate x squared gives you 2x. Differentiate 5 gives you 0. Differentiate x squared minus 9 also gives you 2x. So we say that both x squared plus 5 and x squared minus 9 are antiderivative of 2x. In fact, if you differentiate any function of the form x squared plus c, where c is a constant, you get 2x. So in this case, x squared plus c is an antiderivative of 2x for any constant c. In general, if big F is an antiderivative of small f, then big F, the function big F plus any constant c is also an antiderivative of the function small f, because differentiate big F, the function big F plus c, is the same as differentiating the function big F with respect to x, which gives you small fx. And we also write big fx in this way: integrate small fx dx. And we call big F the indefinite integral of the function small f. Next, we look at the geometric interpretation. The geometrical interpretation of the process of integration is to find all curves y equal to big fx plus c, which has slopes small fx at x. So which means x squared plus 1, x squared minus 3, they all have the slopes equal to small fx, which is 2x. So all these curves, they differ by the constant c, is of the form x squared plus c, and if you differentiate, you get 2x, which is the small fx. So all curves big fx equal to x squared plus c. All curves of the form x squared plus c will have slope fx equal to 2x. So in this example, you can take big F as x squared. So all functions of the form x squared plus c, right, will have slope 2x.